What's going on, you guys? So today we're going to do linked list cycle. So the idea behind this, so we're given the head of a linked list, determine if the linked list has a cycle in it. So there's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause does not pass as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Follow up, can you solve it using O1 memory? So there's a trick behind this question, and if you didn't know it, it would be tough to solve. So I'm just going to tell you guys and show you why it makes sense and why it works. So let's say we have 3, 2, 0, 4, negative 4. So we're going to use 2 pointers, and one is going to go twice as fast as the other. So to start, they're both going to be in the same spot, but the 2 is going to jump 2 steps, and the 1 is going to jump 1 step. So in this case, there's a cycle that points from negative 4 to 2. So we're going to, on each iteration through this loop, we're going to move our respective pointers. So one is going to move here, this guy's going to move there, this guy's going to move here, this guy will move to negative 4 and then back to 2. And at each iteration we're going to check and see if they're equal or not. So this guy's going to move here, and this guy's going to move 2, 1, 2. Oh, and they're equal. So we would return true. There is a cycle. Whereas, let's see what happens if the last element was actually null. So let's see what happens here. So this guy moves 1, this guy moves 2, this guy moves 1, he moves 2. Okay, and so we would, if we reach null, we would go ahead and return false, because there's no way, like if we keep going, so we move this guy, and then 2 dot next will just be null again, and then we move this, and 2 dot next, and then null equals null. We don't want to return true when they're both null. So when either of them, when their next step is going to be null, we're gonna exit out of our loop and return false. So so what are we gonna do? We're gonna have a variable, let's call it 1 step. We're gonna set it equal to 1 step dot next. And we're going to have 2 step, and we're going to set it to 2 step dot next. Dot next, right? So it's going to jump twice. And we're going to check if 1 step equals 2 step, then we'll return true. There is a cycle. And when are we going to, let's see here. So while okay, let's update that. Okay, so otherwise we're going to return false. So thinking about when are we gonna hop out of this? When have we determined there's not a cycle? So if the next value for either of our pointers is null, then we know that this linked list does not have a cycle. So if 1 step dot next does not equal null, we'll continue in the loop, because if it is null, then we need to exit out and return false. And if our 2 step 2 next, because it's jumping twice, does not equal null. So we do these question marks because that will eliminate a null pointer exception. That's a feature of Kotlin where if one step is null, it will just return null in this case. Okay, let's think about this. Oh, and also, so if head equals null, we're just going to return null. Okay. Yeah, so that's just a little trick on this one, and if you don't know that one, you're going to struggle with this. Let's see here. Null, what's the problem? 13. Oh, we're returning false. What's the problem here? Unresolved reference one step. Oh, we have to make our, so var one step equals head, and we'll do the same for two step. Okay. Let's see. Okay, there you go, guys. This is the two-pointer. One moves twice as fast as the previous one. It's a little trick. Yeah. So go ahead and the idea behind like getting used to this one-step, two-step pointer, two-pointer thing is you just got to do a lot of problems and get used to recognizing, oh, I'm going to use the one-step, two-step, two-pointer trick on this problem. And you just have to develop pattern recognition to figure out when you should be doing that. All right, guys, stay tuned for the next one. See ya.